At this point, our Tetris game is starting to look pretty good. It's not totally polished, but most of the features that we need for a complete game are here. We can move pieces, we can rotate them around, we can do a soft drop and a hard drop. All the core things that you would expect from a Tetris game are here, except for the ability to lose. One of the things you can't do in this game is ever lose. Even if you get all the way to the top, and we let the final few pieces fall here, the game is just going to keep generating pieces. You never actually, the game never ends. And so one of the first things I want to do in this video is allow the game to end, create a game over state. And then after that, we're just going to be doing a little bit of polishing up to make this game complete. So to detect if you've lost, what we want to do is when you generate a new piece, and I have that custom block here, we want to check whether or not that piece is valid. Because if the moment a piece spawns, it's invalid, it's already overlapping with another piece that already exists on the grid, that's how we know the game is over. That's how we know we've lost. And so in order to do this, it's pretty straightforward, thanks to the way that we've programmed this. After we generate a new piece, all we have to do is check if it's valid. And we can just plug in all of the different sort of values that we have. Now, I don't remember what order they go in. I think it's piece X, piece Y, rotation, and then type. But I'm not totally sure. I guess we could probably check somewhere. Check if piece valid. We've got piece X, then Y, then rotation, then type. Yes. So those are in the right order. And after we check if it's valid, we need to do something if it's not. So I'm just going to say if is valid is false. If the piece, as soon as we generate it, is immediately overlapping with something else, if it's not valid, then we want to end the game. Now, we could do a big sort of end screen and stuff, but I'm going to leave that as an exercise to you. If you want to follow along and make your own Tetris game or remix the project that I've created, you could create some sort of cool end screen, and I think that would be a really neat addition. But for now, we're just going to put a stop all. So as soon as, if we fill up the board here, we'll let the final few pieces fall slowly. Hopefully, when the board fills up, the game will end. So there we go. Right now, the game stops. Yes, you can see the green flag is no longer lit up, and the game has stopped running. So that's good. That's one of the final key pieces that we need in order to make this game good. Now, there are a couple of little final touches that I also want to add. One of them has to do with the way that we're generating random pieces. You might have noticed right at the end there, it was kind of a coincidence, we generated 3 eye pieces in a row. Now, in a real Tetris game, that would never happen. Tetris is sort of designed to be sort of random, but also sort of predictable. And one of the ways that they do that is using something called a random bag. And the idea is that instead of picking the piece type completely randomly, where here we're just using a pick random 1 to 7, we want to sort of have a predictable way that the randomness is happening, while still, of course, being random enough to keep the game interesting. So what happens is we have what's called the random bag, and it's essentially, you can imagine it as one big bag that contains one of each type of tile. So you've got one of the I pieces, one of the T pieces, and so on. And then, each time you go to pick a random piece, rather than just doing a pick random 1 to 7, you're going to draw one of the pieces out of the bag. So you'll choose one of the options randomly, but you only get to choose from what's remaining, from what you haven't already picked. Then, when the bag is empty, you refill it with 7 new random pieces. And what this means is that you can never have more than 12 pieces in a row between getting the same type of piece 2 times. So if you get an I piece, that's the really good one that you want, that's 4 sort of all in a line, there are only going to be 12 non-I pieces in a row until you're guaranteed to get another I. So it's still random, but it's less random, and it makes the game a little bit better. So let's try doing that right now. In order to create our random bag, we're going to use a list, and I'm just going to call it random bag. And the idea with the random bag here is that we can reset it right off the bat. We can say delete all of random bag, and I guess we'll do that kind of when the game begins. So we got to go up here to where the game starts. And before we generate our first new piece, we'll just clear out the random bag. Then, when we go to generate a piece, if the random bag is empty, we want to refill it. So we need to detect if the random bag is empty, and we'll do that just by checking the length of the number of items in the bag in this list. So we'll get the length of the random bag, the number of items, and if it's equal to 0, that means that the random bag is empty. And if that's the case, we need to refill it. So in order to refill it, we're just going to add the numbers 1 through 7 in order, one of each type. And it's okay if they're in order, because then we're going to select pieces out of the bag randomly. So I'm just going to use the variable n. We could, of course, just say add 1 to random bag, then add 2 to random bag, then add 3 to random bag, like this, and just use a bunch of blocks, and that would work. But it's kind of nice to have a repeat loop that's doing this for us. So we're just going to repeat 7 different times, and we're going to add the variable n to the random bag. And then we'll change n by 1 so that we get 1 of each different number. So if I click this, you can see we get 1 through 7 in the random bag. So anytime that the random bag is empty, we're going to refill it. Then we know for the rest of our script that there's at least 1 item left in our random bag. So what we want to do now is randomly select an item from the bag and then use it as our piece type and delete that item from the bag. So the first thing we're going to do is choose which list item we want. So we've sort of used the variable n here in this repeat loop, but we're done with it in this context, and so I'm going to reuse it as a new variable. And this is going to be the list item that we choose. So we could choose list item 1, list item 2, list item 3, and so on. But the number of options that we have depends on how many items are left in the bag. So we're going to choose pick random 1 to the length of the random bag. So if there are 4 different pieces left in the bag that we can choose, this will be a pick random 1 to 4. And so this is not necessarily going to give us the value, it's not necessarily going to give us the piece type we choose, but it's going to give us the sort of item number in the random bag that we're selecting. And there's a reason that that's important. First of all, though, let's say once we've chosen which list item we're going to use, let's get that list item out of the random bag and set it to be the piece type. Now, the reason that we've done this and stored this in n is so that we can delete the piece from the random bag after we use it. So after we grab a random piece from the bag, we're going to remove it. We're going to say delete item n, the one that we've selected, out of the random bag. All right, so there's this random bag approach now. And hopefully this will be working, as long as I haven't forgotten anything. I'm just going to put this list here, and we can try it right out of the gates. So you can see we started with 1 through 7, but now we have 1, 2, 3, 4, 5, 6, and piece type 7, which is this orange piece, is the one that we've chosen. Now when we go to select the next piece, we delete another item. It looks like in this time we chose piece type 3, and so that's been removed from the bag. Then, when this one gets to the bottom, we'll try another. Okay, it looks like we've removed 6. So this is piece type 6 here that's falling. And then we removed piece type, I don't know which one went away this time, actually. I think maybe 2. Then we removed 4. Then we removed 1. And so we know that the next piece we get is going to be piece type 5, the one that we haven't seen yet. I believe it's the red piece. Yeah. Now you can see our bag is empty. And so the hope is that this little script at the beginning that refills our random bag is going to run, and we'll get 7 items in the bag, but then 1 will be immediately removed. And so we should have 6 items in the bag. Yes, we can see we've got a length of 6 because piece type 2 got removed instantly. So there you can see now our random bag is in place. And so we've got sort of the random tiles being generated, but it's a little bit more predictable. And I think this makes the game just a little bit better. Now, there's one last sort of touch-up that I want to make in this video, and then after that, we'll have just one more video of tweaks and touch-ups to sort of complete this game. So the last thing I want to do right now is deal with the fact that the pieces can be drawn, the falling piece can be drawn even when it's above the board. We've sort of been looking at this the whole time, and I've been putting off fixing it because it's actually kind of useful as you're building the game to be able to see the tiles while they're above the screen. But you can see, like, right now we're off screen, and that's not really good for actual gameplay. This should be an easy fix here because we can just go into our render grid custom block, and we can find the part where we're drawing the falling piece. Let's see. It looks like right here, we're getting the piece coordinates of the falling piece, and then we're drawing them. And so the only thing that we want to do is say, when you go to render this tile, only render it if it belongs on the board. In this case, remember that our grid contains 2 rows at the very top that don't get drawn. Row 1 and row 2 are supposed to be off the screen. And so we only want to draw the tile if the tile's y-coordinate, which is what we're getting here, if the tile's y-coordinate is greater than row 2, if it's row 3 or above. And so hopefully now, yeah, you can see that those 2 rows that are invisible, that are off screen, are actually not being drawn anymore. All right, we've got a couple more touch-ups to make in the next video, and then this game will be completed, and sort of I'll hand it off to you to hopefully have your own ideas for making this game better.